Sampling. When carrying out a statistical investigation, there is going to be a set of things you are interested in. For example, the registered voters in the UK, the cars produced by Kia in 2020, the students at your school. The set that you identify is known as a population. If you collect data from every member of a population, it is known as a census. It is not always practical to collect the information we want from every member of a population, and we'll look at this later in the examples. Even if it is possible, it might be too costly or time-consuming to be practical. In cases where we want to carry out a survey, but it is not practical, we could run our survey with a subset of the population. Such a subset is known as a sample. Once we have our data, we may calculate things from it, such as the mean or the standard deviation. If these are based on a population, then they are known as parameters, and you often hear people refer to population parameters. If based on a sample, they are known as statistics. The objective is that any statistics calculated from a sample would be representative of the population parameters. If a sample is not representative of a population, it is said to be biased. Bias is possible in any type of sample, but some types of sample are more inherently flawed than others, but sometimes we just have to use those methods anyway. Statisticians would normally try to reduce the amount of bias in samples, for example, by using a random sample where possible. Sometimes people talk about probability-based sampling when they're talking about random sampling. We will look at some types of sampling shortly. Let's first look at census and sample and some advantages and disadvantages. This should give an accurate view of the population. At least it gives a snapshot. With some censuses, there's so much information, but that by the time it's processed, the situation may well have changed within the population. So it's a snapshot at the time that the census was taken. It's not possible to do this for an infinite population. It can be time-consuming and expensive. And testing to destruction is not possible. See an example to follow. A sample can be used in situations where a census is impossible due to an infinite population or impractical. It's quicker and cheaper than a census in general. But it may not be representative of the population. In some cases, it is possible to list every member of a population. For example, you could get a list of every student at your school. If we assign each student a number, we form what is known as a sampling frame from which we can draw our sample. If we have a sampling frame, we can use a probability-based method to choose a sample. And three probability-based methods that we're going to discuss here are simple random sampling, systematic sampling, and stratified sampling. With simple random sampling, every member of the population is equally likely to be chosen. For example, suppose we had a sampling frame with 1,000 individuals and we want a sample of size 40, we just generate 40 random numbers between 1 and 1,000 and use those people that come up as our sample. If we have a sampling frame with 1,000 individuals and we want a sample size of 100, that means we want 1 in 10 of the individuals to be in our sample. What we do with systematic sampling is we choose a number between 1 and 10 at random and then take every 10th person from there. In other words, in this example here, I've generated 6 as my random number, and then I just count every 10th person from there. So 6, 16, 26, 36. With stratified sampling, a good example here would be if we can see distinct groups in your sampling frames, such as with the 1,000 individuals from a school, we might have year 7s or year 8s. With stratified sampling, we want proportional representation from each year group. So what we do is we split the sampling frame into the year 7s, year 8s, and so on, and then we carry out a simple random sample within each group, so that if there are twice as many year 8s in our population, we end up with twice as many year 8s in our sample. Sometimes, however, we just can't produce a sampling frame. For example, we probably would have no way of knowing who the customers will be at a supermarket on a Wednesday. In this case, we will have to take a non-probability based sample, such as an opportunity sample or a quota sample. With opportunity sampling, we just take samples from members of the population we have access to until we have a sample of the desired size. For example, you may have been asked to do a taste test at a supermarket. With quota sampling, it's like opportunity sampling. We use the population we have access to, but like stratified sampling, we have distinct groups. We continue until we have the quota for each group.